Now let us explain what we mean by differentials. So for the differential we will learn what is the difference between delta y and dy and also delta x and dx. So this will be in definition 4.9.2 differentials. The differential of the independent variable x is the non-zero number delta x and is denoted by dx. So the differential of x will be delta x and it is equal, we have dx is equal delta x. If f is differentiable function at x, then the differential of the dependent variable y is denoted by dy, that is dy is equal f prime x multiplied by delta x. And we said that delta x, it is just d of x. So dy will be f prime x d of x. So we have two types of differential. Differential of the independent variable, which is dx is equal delta x, and differential of the dependent variable y, which is dy is equal f prime x d of x. So we conclude from this definition that dx is equal delta x and dy is equal f prime x delta x or f prime x dx, f prime x dx or f prime x delta x, but delta y will be equal f x plus delta x minus f of x, the difference between the two values of f. So we'll take f plus f multiply f of x plus delta x minus f of x. يعني هنا ال dx هي نفسها ال delta x، بينما ال dy هي عبارة عن f prime x delta x أو f prime x d of x، لكن ال delta y ما نفسها dy، لا، ال delta y عبارة عن f x plus delta x minus f of x. So distinguish between two things. dx is equal delta x, but dy not equal delta y. So let us see an example. Find dy for y is equal x squared cosine 3x. So we need to find dy. We said that dy is equal f prime x multiplied by d of x. So let us differentiate this one. So dy over dx will be equal, here we will use the product rule. Derivative of x squared will be 2x multiplied by cosine 3x minus derivative of cosine 3x. Since we have the product rule, here should be plus, but here we have cosine, we need to differentiate cosine. So from here we get minus sine 3x, derivative of 3x will be 3. So now the derivative of cosine 3x will be minus 3 sine 3x, and we need to multiply it by x squared. This is dy over dx, but we ask to find dy. So we will put dy in one side, so dy will be equal this one multiplied by dx. So to find dy, first you find dy over dx, then put dy in one side and multiply this one by dx. Then we have another example, which is exercise number 36. Find delta y and dy, where y is equal 3x squared minus 5x plus 6. So for this one, to find dy, first we need to find dy over dx. So the derivative will be 6x minus 5. So dy will be 6x minus 5 multiplied by dx. Now to find delta y, we said that delta y is different than dy. So delta y is equal f x plus delta x minus f of x. We will go to the function y, we will replace any x by x plus delta x to evaluate what is fx delta x or yx delta x, and then we subtract fx, which is this function. So here we have 3 multiplied by x squared will be 3x plus delta x squared minus 5 multiplied by x, it will be x plus delta x plus 6. So all this will be fx plus delta x, then minus fx, which is the function 3x squared minus 5x plus 6. So now then we need to simplify this. So x plus delta x all square multiplied by 3, this will give us 3x squared plus 2 multiplied by 3 multiplied by x multiplied by delta x will give us 6 delta x multiplied by x plus delta x squared multiplied by 3, so it will be 3 delta x squared, then minus Here we have 5 multiplied by x, so 5x, minus 5 multiplied by delta x will be minus 5 delta x, plus 6. Then here we have minus 3x squared, minus with minus will be plus 5x, minus with plus will be minus 6. So we see we can cancel 3x squared with minus 3x squared. We can cancel minus 5x with plus 5x. We cancel 6 with minus 6. So we left with 6 delta x multiplied by x, which is this one, minus 5 delta x, which is this one, plus here we have 3 delta x squared. So delta y will be 6x delta x minus 5 delta x plus 3 delta x squared. So from this example we see that dy is different than delta y. Then we have exercise number 46, part A. Find an equation of the tangent line to the graph of fx is equal x cubed plus 3x squared at x is equal a. To find an equation of the tangent line, you need a slope and you need a point. So for the slope, first we need to find the derivative. F prime x will be 3x squared plus 6x. So f prime, we are given x is equal 1, so f prime 1 will be 3 plus 6, which is 9. To find the point, we need to find f1. So f1 is equal 1 plus 3, this will give us 4. So here we have a point which is 1, 4, we have a slope 9. So we know that the linearization and the tangent line, they are the same. So Lx is equal f1 plus f prime 1 multiplied by x minus 1. This is the equation of the tangent line at x is equal 1, where f1 is equal 4 and f prime 1 is equal 9. So Lx, or the derivative or the equation of the tangent line at x is equal 1 is equal 9x minus 5. So if he said that find an equation of the tangent line or the linearization of the function, it will be the same. Just use this. Lx is equal fa plus f prime a multiplied by x minus a. Then we have another exercise, which is number 30. Use an appropriate function and local linear approximation to estimate the value sine 1. So here we need to find a function which is fx. We need to find also a. So here, since we have sine 1, so if we assume or let our function f of x is equal sine x, because here we have sine 1, so we need to evaluate sine any value. So we will choose that fx is equal sine x. And if we assume a is equal, for example, 0, you can choose any number for a. But here we write it is 0 because we know that sine 0 is equal to 0, so this will simplify our evaluation or calculation. So that's why I choose here a, for example, is equal to 0. You can also choose a is equal by or by over 2, whatever. But use whatever you feel it is easy and it will simplify your evaluation or calculation. So if fx is equal sine x and a is equal to 0, then we need to evaluate what is f0. It is sine 0, which will give us 0. And f prime x will be the derivative of sine, which is cosine. So we need to evaluate f prime 0. This will give us cosine 0, which is 1. So now the equation of the tangent line of f at x is equal to 0, which will be y minus, we have what is y1, which is f0, which is 0. So y minus 0 is equal. What is the derivative of, or what is the slope? The slope is f prime 0, which is 1. So 1 multiplied by x minus x1. x1 we said it is 0, so x minus 0. We will get y is equal x. So the linearization of fx at a is equal to 0 is sine x is equal Lx is equal x. Then a linearization for sine x, it is equal x. We need to evaluate sine 1. So now we have sine 1. If you rewrite 1, this is in degree. If you write it in the radian, it will be pi over 18. Pi over 180, sorry. So since we said that sine x is equal x, so sine 1 should be equal sine pi over 180, which is equal pi over 180. If you want it in degree, it will be sine 1 will be equal 1 degree. But here I write it in radian. So I convert first 1 to pi over 180 in radian. And we say that sine x, it is just x. So sine pi over 180, it will be just pi over 180.